Recently, I traveled to Key West with several other marine journalists to spend some time on the water with Dometic's new DG3 Gyroscopic Stabilizer. Day 2 of my trip took me out on Dometic's Sea Hunter 37 center console, equipped with the DG3 and a suite of Dometic's power conditioning and other equipment. Our day started off with a quick run out to get some bait, as well as learn a little bit more about the gyro. The cover on the DG3 comes off without any tools. The specific install on this boat is a little bit tight, so it took an extra moment to pop it off, but once all the captive hold points were released, the cover pops off. Now let's hear a little from Joey Greenwell, Dometic Application Engineer, on the DG3.
Yeah, this leaning post, we modified it to put that in there. It wasn't designed for it necessarily. It's tight, but it works pretty good. So a lot of little things that made me fall in love with this gyro. Our cover lid pops right off. It's got these rubber keepers, just like pulling a cover off a car engine. So it's really easy to get to. Engineering's done a fantastic job. There's no specialty tools that you need to work on this thing or service it. You basically need a Torx, a T20, a T25, an 8, 13, 14 millimeter wrench, and that's all you need. So it's very easy to work on. It's well thought out. If you do have to take any of these covers off, all of these screws are captive, so when you loosen them up, they're not falling down into bills. When you first fire this thing up and you hit the power button, this thing will process, which is what we call it when the sphere moves. It'll process each direction, and it's calibrating our electric actuator. Every gyro up to date is purely reactive. So because this thing is only able to process forward and aft, and the flywheel is spinning on a vertical axis, we need the boat to roll. Traditionally, with all the other gyros, you need the boat to roll to make this sphere move. On the Seakeeper units, they've got a hydraulic brake system. So we're able to deal with some wave conditions that up to this point nobody's dealt with. For example, if you get into a situation, let's say a boat drives by here, and you get those real close waves that you get from a wake, and you kind of get that oscillation. Traditional gyros have a real issue dealing with that. Eventually what it'll do, it'll kind of ratchet over, and then it'll bottom out where they have no more precession, no more travel. And again, that sphere's got to be moving so that you can fight it to get your corrective action. We're able to actually bring it back each time. And our IMU, which is a inertial measurement, you take that input into our little computers, and yeah, this thing, if it's in a condition where it thinks it's going to run out of precession before the wave's over with, we can actually pull it back a little bit. So with traditional gyros just being purely reactive, you're limited, again, on the wave conditions that you're able to really get good stabilization on. Because we're able to make this thing do what we want it to do, performs at a much, much higher level. When I talk about we're able to actively control this thing instead of passively like everything else, so now I'm making it. Now we're not going to go a lot, but we can get this thing to touch rub rail to rub rail in the water. Say you're on a traditional gyro, and we're out here doing this, and then a boat comes by, right? And you get those real short wake waves coming off. So you start an oscillation, right? Which is when your wave periods start to get close to the natural roll period of a boat, you'll get this oscillation. And it's difficult for traditional gyros to deal with that, because sometimes what it'll do is it'll ratchet kind of. Because you remember, you need the boat to roll to make the sphere move. We're able to recognize what's going on, and that oscillation, if we need, we can pull it back. So we're not ratcheting until you bottom out your precession. We're actually able to control it. Lots of companies have put multiple gyros in boats, and traditionally they didn't have to communicate, they didn't have to be networked together. You could have two gyros right next to each other, and it can't tell the difference between a smaller wave or a gyro right next to it helping out. So it can't tell the difference. We're looking at being able to network these things together with the active precession, and maybe stage these things So in long duration waves,
one's
we
on
can
and then the
stage
other.
one so that one picks up, so after the first wave or two and our gyro control unit recognizes what's going on, we're able to phase these things in or stage these things in to match the phases of the wave much better. And nobody's ever even done that before. We have no maintenance on the heat exchanger. That's a maintenance item. We have no zinc anode. That's a maintenance item. All of these pivot points where our actuator is and where the gyro control arms, those pivot points, competitors, they have bushings in there, fiber bushings that need to be replaced. And that's basically like the brakes on your car. It's hard to anticipate that. It's just the use, how rough it's been, how much you've used it. This unit is designed, it does not have bushings in all those pivot points. It has sealed needle bearings that actually have seals and O-rings, and they're designed for the life of the gyro. So there's no maintenance there. There's a little box over here, kind of looks like the size of two hot dogs together. It's a solenoid. We actually have a brake so that if this thing were to encounter an error or a fault where it would need to turn itself off, we're also able to capture the sphere. In the event of a catastrophic failure, we're able to capture that sphere and keep it from processing. So the safety factor in this is higher too.
After our orientation session on the gyro and collecting some bait, it's time to head out to the fishing grounds. We headed a few miles offshore and found some pretty good water to demonstrate the capabilities of the gyro. As we slowed down, the quartering seas pushed the boat around pretty well. The gyro controlled the motion nicely, though we did have a few opportunities to turn the gyro off and see what things would have been like. Unfortunately, I did not grab footage of the boat rolling. My hands were a little busy.
And then crank down. There you go. Pull up. Crank down all the way down. Crank, 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 crank. Up. Crank, 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 crank. All right. Up. Crank, crank.
After several hours on the water, we hauled some fishing, got the opportunity to enjoy a stable day on the water fishing, and with that, it was time to head back in.